Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Momentum, the law of conservation of energy is today's topic. So this is continuation of the previous momentum playlist that I recommend you start from the beginning. The link is in description. And also previous two problems were about head-on collision. I recommend you watch those two. But today I will be talking about completely elastic collision, but not head-on. So it's one billiard ball and another billiard ball, and it doesn't hit in the center, it hits a little bit like this is head-on collision, but what I will be talking about when they are not like this, and so when it hits like this, and after that they fly under different speeds and after at a different angle. This flies at alpha and this flies at beta. And what they want us to do, of course, the mass is exactly the same. The previous problem was about head-on, and this was V, but this is the same masses, all the same, and the same V, but they fly at different angles. It's not head-on, and you know how it is in the game of billiard. And it is V1 and V2. So what we do here, we have the law of conservation of momentum. That momentum, vector of momentum doesn't change, it's a constant. So we have initial momentum is this. This is P initial is mv. And in the end, what we have final, it is this vector mv1 plus vector mv2. And of course, we can say that initial momentum equal the final momentum. This is the power of the law of conservation. And so then, of course, how we solve it? Of course, let's solve it first using x and y coordinate system. And let's do on x. On x, we have initial momentum is equal mv, the projection of this is mv. And final momentum consists of 1 mv cosine alpha plus mv2 cosine beta. Right? Because we have two projections from this and projection from this. Projection for this is cosine, projection from this is in cosine beta. They all in positive direction, so plus sign here. And if you have problem with this, please read pre-request playlist about vectors and pre-request playlist about trigonometry. And now on the y-axis, initial momentum is 0. Initial momentum, its projection on this is 0 because it's perpendicular. And we have this one mv1 sine alpha. And this would be minus mv2 sine beta. And those are two equations, and we have alpha is unknown, and beta is unknown, and v1 is unknown, and v2 is unknown. So there are 4, and we have only 2, right? Of course, m is also unknown, but m would be cancelled out here everywhere, right? What we can do, because we haven't used one word from the problem, is that it is ideal elastic collision. That means that the law of energy is only kinematic energy, no other energy here. Before it is mv squared over 2. In the end, it's kinematic energy of the first body and the second body. And those are three equations, and again m is gone. Alright, so let's reuse this space and let's rewrite it again. So we have v equal v1 cosine alpha plus v2 cosine beta, and here we have 0 equal second equation v1 sine alpha minus v2 sine beta, and the second one is v squared equal v1 squared plus v2 squared. And this is basically the same that is here, so let me wipe it out. So again, this is basically x component of the law of conservation of momentum, this is y component of the law of conservation of momentum, and this is the law of conservation of energy, in this case kinetic energy only. Still only three equations, but they don't ask us about everything. They ask us only about the angles. So here is a trick, obviously. And this trick, we have squared, 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 and we have this and this. Let's square this one, and let's square this one, and then let's add them together, but let's do slowly. First I square this. A plus b squared means v1 squared cosine squared plus 2 v1 v2 cosine alpha cosine beta, and let me wipe it out because this picture is kind of obvious. We have it, and plus v2 squared cosine squared beta. All I'm using a plus b squared equals a squared plus 2ab plus b squared. Nothing more. And this is again pre-request playlist algebra, it's a basic formula. Only here this is v squared and this is a. So this is a squared. Plus double a multiply on b. So this is multiplication. And then plus this square. Then let's do the same thing here, only the formula will be a minus b, and it would be the same, only sign would be different. So I square this, it would be 0, and this would be v1 squared sine squared minus 2v1 v2 sine alpha multiplied by sine beta. And plus, of course, let me wipe it out because we already know those formulas, I'm sure you do. Plus this one, v2 squared sine squared beta. So once again, I square this left would be 0. This would be this squared minus 2v1 v2 sine alpha sine beta. I change the order, it doesn't matter, plus this squared. And I don't want even to rewrite this because all I want to add this. And you will see why I want to add this. Because if I add this, I will have v squared. It would be pretty much like this. And when I add those, it would be v1 squared cosine squared plus sine squared. This would be, because I'm adding those two, they both have v1 squared, so I factor it out. And so from the first would be cosine squared, from the second would be this. When I add those two, I will have 2v1 v2. I will factor those out. First we'll have cosine alpha, cosine beta, and from this one it would be minus sine alpha and sine beta. Alright, and then I will add those two, and again I will have v2 squared cosine squared beta in this case, plus sine squared beta. Alright, and then I will have v squared, and of course this is 1, so it would be v1 squared. And let me rewrite this first, cosine plus sine squared, it's 1, so it would be plus v2 squared. And you see what happens, this is exactly like this. And of course, to see it ahead, you need to be a little bit proficient in math and trigonometry and in algebra, but that's what it is. It's not like rocket science, nothing like that. And then I have plus 2 v1, v2, and this is a very important formula from trigonometry. Trust me, I don't want to derive it, I don't want to remind you, but the formula is cosine alpha plus beta. And that's basically it. And then if I look on this, I say that this squared equals this. So I can put it here and cancel it out, but I can cancel it out right away. V squared equals this. I can put it here, and cancel. So those are gone. And instead of those two, I have 0 equals 2v1, v2 cosine alpha plus beta. Alpha plus beta. And what that means? 0, it means that cosine alpha plus beta equals 0, and this means that alpha plus beta equal 90 degrees. It's basic things with trigonometry, with cosine function. So, this was rather complex, and in the next installation of this problem I will solve it a little bit more elegant, a little bit more faster, using vectors themselves, not using projections at all, but using just vectors. And but the point is the same, that if I hit this ball and hit this ball, and this is not a head-on collision, then this ball will be moving at angle alpha, this would be moving at angle beta, and alpha plus beta would be 90 degrees. So they will fly at 90 degrees, and it's very important for those who play billiard, because they not often do a head-on collision, but at the angle. And that's basically it for this installation. So thank you very much. Like, subscribe, bell, problem, question, put your comment, and I see you next time. Thank you.